ഇവിടെയാണ് നിർത്തിയിട്ടുണ്ടായത് കഴിഞ്ഞ ക്ലാസ്സിൽ. we had written the equation for parallel planes and two parallel planes separated into infinity parallel planes. Thereafter cylinder, concentric cylinder. Concentric ആണ്, രണ്ട് സിലിണ്ടർ വേറെ വെച്ചിട്ടല്ല, one cylinder upon another, and it means that the center for the both cylinders are same, small cylinder and big cylinder. So we have written the particular equation for particular regularities. F12 of sigma F12 of sigma T1 raised to 4 minus T2 raised to 4, right? So the connection problem ഞാൻ ഇന്ന് കോഡ് ചെയ്യാം കേട്ടോ ഫോണിൽ. അപ്പോൾ in this condition we have written that the question is asking like that, ശരിക്കും ഇക്വേഷൻ ഇങ്ങനെയാണുള്ളത്, Q12 equal to F12 small f12 capital F12 into area into sigma T1 raised to 4 minus T2 raised to 4. That is the correct equation, but here we are taking that F12 equal to 1, F12 equal to 1, and area is equal to 1 meter square. That is F12, capital F12 with the shape factor. Shape factor is stating as 1, and then area is stating as 1 meter square. So we are reducing that equation into Q12 equal to F12 sigma T1 raised to 4 T2. If there is area is there, if area is given or length and breadth is given in a question, you want to take a particular area. Area is A1. Q12 equal to F12 into A1 into sigma A1. You want to take the first area. First area means the heat transfer is happening from Q1 to 1. Q1 to means Q of 1 to 2. 1 from 1 to 2. So we are taking the first area A1. If it is Q21, we are taking A2. Okay. So please write down a problem, a simple problem to understand the application of the particular equation. Determine the rate of heat loss. Determine the rate of heat loss by radiation. Rate of heat loss by radiation from a steel tube of outside diameter 70 mm, outside diameter 70 mm, and 3 meter long, at a temperature of 227 degrees Celsius. If the tube is located within a square brick quantity of 0.3 meter, 0.3 meter side, square quantity of 0.3 meter side, and at 27 degrees Celsius. Okay, first stop. Take emissivity of steel. It is emissivity of steel equal to 0.79, and emissivity of brick equal to 0.93. Okay, this is our question. Determine the rate of heat loss by a radiation from a steel tube of outside diameter 70 mm and 30 mm long. Okay, outside diameter 70 mm, 30 mm, 3 meter long, at a temperature of 227 degrees Celsius. Therefore, T1 initial temperature, that is particular heat transfer is happening from that steel tube. We can draw a particular figure. വായിച്ചു നോക്കാം എങ്ങനെയാണ് ഏത് ഇക്വേഷൻ എടുക്കണം അറിയാൻ വേണ്ടി. A steel tube, okay, a steel tube of diameter, given data, diameter equal to 70 mm. 70 mm means 0.07 meter. Okay, and length equal to 3 meter. Not 3 meter. 3 meter. Yes, it is 3 meter. 3 meter. That is a particular diameter of particular this outside diameter of this steel tube is 0.7 meter, and length means the particular figure is like that. ഇങ്ങനെയാണ് figure ഉണ്ട്. That particular length is given as 3 meter, and meter long at a temperature of 227. At a temperature of 227, that is T1 equal to 227 degrees Celsius is equal to 227 plus 273. That is 500 Kelvin. T1. Okay, is located within a square brick quantity. Within a square brick quantity. And that particular steel tube is inside a square brick quantity. Like inside a square brick quantity. It is within a square brick quantity. The particular steel tube is within a square brick quantity of side 0.3 meter. 0.3 meter. മനസ്സിലാക്കുക. The particular steel tube of outside diameter 70 mm and 3 meter long at a temperature of 227 degrees Celsius if the tube is located within a square brick quantity of 0.3 meter side and at a 27 degrees Celsius, and therefore T2 equal to 27 degrees Celsius is equal to 300 Kelvin. Which means the heat is transferring from this body. Like heat is transferring from that particular steel tube. Heat is transferring from the particular steel tube to outside. As therefore T1 is here and T2 is here. Okay, it is a given problem. So which equation we want to take? Which equation we want to take for the particular problem? We have studied. We had taken 3 or more type of equations for the last class. That is for infinite parallel planes. Is it a problem of infinite parallel planes? Is it a problem of infinite parallel planes?
No.
No. So next question was infinite long concentric cylinders. Long concentric cylinders. It means concentric cylinders in the problem alla. It is not a problem of concentric cylinders, but it is a particular cylinder is there. One is there, and next one is a square brick. Next one is a square brick quantity. It is not a cylinder. It is not a two concentric cylinder, but a concentric cylinder and a particular cylinder and a particular square. But okay, both the particular figures have a same center, right? Both the particular figures, that is for square brick quantity and the steel tube, that is we are taking a cylinder and have a same center. So it is a case of a concentric figures. That means first one is particular square and the second one is particular a steel tube, but both has a similar and a small and a same point of center. So we can take that particular equation. We can also take the particular equation in this case. വേറെ പ്രോബ്ലം നമുക്ക് അത് മിസ് ചെയ്തിട്ടില്ല അല്ലെ. വൺ ബോഡി enclosed and therefore two triangles the common edge. There is no common side right angles, triangles equation, rectangle equation, parallel plane equation. This is not type of problem. It is that type of problem where concentric cylinders or a particular body enclosed by a large body. Particular body enclosed by another body, we can use the same equation. As Q equal to equation, that is a particular concentric cylinders and a body enclosed with another body. A body enclosed by another body has a similar equation, that is Q equal to F12 of F12 sigma T1 raised to 4 minus T2 raised to 4. T1 raised to 4 minus T2 raised to 4. And here area is given. All the sides is given. So we want to compute the area, that is F12 into A1. F12 into A1. F12 into A1. F12 into A1 into sigma T1 raised to 4 minus T2 raised to. So find the value. That is the value of F12 here. F12. First you want to find F12. 1 divided by
1 by epsilon 1 plus A1 by A2
1 by epsilon 1 plus 1 by A1 by A2. A1 by A2 into 1 by epsilon 1, epsilon 2 minus 1. Okay. 1 by epsilon 1 plus A1 by A2 into 1 by epsilon 2 minus 1 is the F12 value. So epsilon 1 is given and epsilon 2 is given. Epsilon 1 is given and also epsilon 2 is given here. So substitute the values to find the equation of value of F12, that is 1 by epsilon 1 is first 1 to 2 1. So the area will be that first area. A1 here, 2 here, 1 to 2. So 1 by epsilon 1 is given as 0.79. 0.79 plus A1 by A2. What is A1 by A2? Here area 1 is of cylinder. Okay, of particular this surface. That is ഇതിന്റെ സിലിണ്ടറിന്റെ സർഫസ് ആയിരിക്കില്ലേ, ദ സർഫസ് ഓഫ് സിലിണ്ടർ. ഇതിന്റെ ഈ സർക്കിൾ അല്ല കേട്ടോ, ഇറ്റ്സ് നോട്ട് സർക്കിൾ, that is not a cross section area but a surface area of cylinder. We are only taking the areas of surface area only here. Surface area മാത്രമാണ് എല്ലാവരും എടുക്കുന്നത്, not taking the particular cross section area, but we are taking the surface area, and by surface area we will get the equation as surface area of the particular cylinder is pi dl or 2 pi rl. Pi dl or 2 pi rl. Pi dl or 2 pi rl, which means 2r equal to d. 2r equal to d, and so pi dl plus area 1 is pi dl divided by A2. A2 means this particular square, not a cross section area of square, but the perimeter of the square, total square and the side. Cube പോലെ എടുക്കുക, ഇങ്ങനെയല്ല ഉണ്ടാവുക. Okay, that particular side, that is square. Therefore this side is same, this side is same, this side is same, this side is same. Therefore 1 plus 2 plus 3 plus 4 into 4, total 4 side into particular 0.3 surface area of the particular square. We are only taking any problem, we are only taking surface area only. So 1 or 2 cases taking cross section area. Here we are taking the surface area, that is A1 by A2. A1 is pi dl, diameter is given, length is given, diameter is given, length is given, and A2 means perimeter into that length, 0.3 into 4. 0.3 into 4 into 0.13 into 1 by epsilon 2 minus 1. That is 1 by epsilon 2 is 0.93 minus 1. We will get the value as value 2. And therefore substituting that particular value, final answer മാത്രമേ. After finding the value, we can find the Q equal to F12 into F12 means you have find out F12 into area 1. Area 1 means area 1, first area, that is inside area, a particular cylinder area, pi dl. Area 1 is pi dl. Pi dl into sigma 1. Sigma 1 is 5. Sigma is 5.67 into 10 raised to minus 8. Stephen Boltzmann's constant. And T1 raised to 4 minus T2 raised to 4. T1 and T2 is given. That is T1 is 500 Kelvin. 500 Kelvin. 500 raised to 4 minus second temperature is 300 Kelvin. 300 raised to 4. Okay. Then you will get the final equation. Final value of the heat transfer. That is, by calculation, you will get the value as 1589.7 watt. നിങ്ങൾ ചെയ്തു നോക്കുക, നമുക്ക് സമയം വെറുതെ കളയാനില്ലാത്തതുകൊണ്ടാണ് ചെയ്യാത്തത്. ഓക്കെ, സോ Q equal to 1589.7 watt by the equation. Only simply substitution of that equation. Only simply substituting the particular epsilon 1, epsilon 2 value, area value A1, A2. So first you want to think what is area 1 and what is area 2. If two bodies are given, which body is treated as 1 and which body is treated as 2? Is we are finding the heat transfer, like the radiation heat transfer from one body to another. So initial body is taken as first body and final body is taken as second body. Okay, from where to where, that is the particular condition FO1 to 2. Okay, so this is the type of problem we are simply using that particular equation, and we will do the more type of problem later. So we can move to our next topic, that is heat transfer, that is shape factor, or for various geometries. Shape factor for various geometries or conditions, various problems. So this is simply by using your data book. Please take your data book and page number 90 plus. 90 plus means simply in your data book will be 90, 91, 92, 93, 94. That pages. There are various conditions. That first condition is the shape factor for equal and parallel squares. Equal and parallel squares, rectangles, disc. Equal and parallel squares, rectangles, and disc. I will show you later, and I'm writing only the main points. After I will show you in the data book. Second particular condition is shape factor for equal and parallel. Shape factor for equal parallel rectangles in opposite direction. That is, question is asked that two rectangle type bodies are placing at a particular distance parallel to one another. Proper. And next one is perpendicular rectangles. Same is parallel, is perpendicular rectangles. The question is like that. Okay, separated by a distance, opposite. If it is perpendicular, we can draw the particular figure as one is kept in here this plane and one is this plane, and they are perpendicular to each other, and they have same edge. Which have same edge. Same edges for both rectangles. Next condition is perpendicular equal squares. Perpendicular squares. This squares is there. And fifth case is perpendicular squares, but not parallel, not perpendicular. It is intersecting. Intersecting squares. Intersecting square means one is at a plane in XY side, one is at a plane, and one is at a particular space, and where particularly arranged at a particular theta degree. Intersecting squares, and like that. And thereafter, last section is the parallel or parallel spaced spheres. Parallelly spaced spheres at a particular distance. Spheres at a particular distance. Okay, these are the particular conditions that given in a data book. 1 to 6 conditions that data book. Because how we can find the value of shape factors F12, shape factor F12 directly from your data book. So please take your data book from page number 91 in your new data book. So I don't know what is the page number you are using old data book. So please take your so page 81, there is the starting of radiation. Page 81, starting of radiation. Here we can see so many equations that we have studied in your previous class and present class. That is, Wien's law is there, Stephen Boltzmann's law is there, Planck's law is there. Okay, lambda max into T equal to 2898 is there. Stephen Boltzmann equal EB equal sigma T raised to 4 is there. Okay, sigma T raised to 4 is given. Planck's law is given here. All the equations are given here, and all the values are given in your right side. What is means, and we have studied for last class reciprocity theorem. A1 F12 equal to A2 F21. Okay, അങ്ങോട്ടേക്കുള്ളത് തന്നെ നേരിട്ട് ഇങ്ങോട്ടേക്കും. A1 F12 equal to A2 F21. Stephen Boltzmann's constant value is given here. 5.6 10 raised to minus 8. And thereafter, next page, here equations that we are studying for this case. നമ്മൾ ചെയ്ത പ്രോബ്ലത്തിൽ it is given in here. It is Q1, Qij. Qij means Q12. We are taking from 1 to 2. Here it is taken from I to j. Okay, it is only difference. So one ij given as Ebi minus Ebj. Ebi minus both and AM is the initial area. ഇവിടെ F12 എന്നുള്ള വാല്യൂ നമുക്ക് പറഞ്ഞില്ല. ഓക്കെ, ഇനി പ്രോബ്ലം ജംഗ്ഷൻ
ഓഡിയോ കട്ടാകും.
കിട്ടുന്നുണ്ടോ?
ഇപ്പൊ കുഴപ്പമില്ല.
കുഴപ്പമില്ല. അത് ഇടക്ക് ബ്രേക്ക് ആവുന്ന കറണ്ടിന്റെ മഴയാണ്, അതുകൊണ്ടാണ്. ഓക്കെ, സോ Fij. So here we another quantity we are using is small Fij. Small F12 we are using, that is our particular value of that epsilon1 epsilon2 are here നമ്മൾ എടുത്തല്ലോ, ആ ഇക്വേഷൻ കൂടി യൂസ് ചെയ്യും. സോ അതൊക്കെ വിട്ട് കഴിഞ്ഞാൽ, സോ ദാറ്റ് one thing I want to show you that page number 90 in our data book and 92 in your new data book. Okay, shape factor for equal and parallel squares, rectangles and discs. This is the first condition. Okay, so how we can find ഈ ഒരു കേസ് വിട്ട് കഴിഞ്ഞാൽ, okay, how we can find the value of particular square shape factors for equal and parallel squares, rectangles and discs. Equal and parallel squares, rectangles and discs. Okay, so here ratio equal to, we are taking the particular ratio value here, x-axis value, smaller diameter or smaller side of the particular given figure divided by distance between the two planes. If the two spheres or two particular rectangle squares is given in your, it's parallelly placed in a particular distance, we are taking that smaller side. If it is square, it is a similar side. We are taking a smaller side of the particular figure, or diameter of the small diameter of the particular figure, and divided by distance between the planes, as taking the x-axis and value gana, and we are taking the particular value here, and thereafter so many curves are there. Curves 1, 2, 3, 4 is direct radiation between the planes. If cosine has been direct radiation between the planes, we can use the particular figure, and 1 to 5 we can use the particular disk in the value, 2, 6 and particular half on and intersect the value, and left side we will get the shape factor F. So ഈ ഫിഗർ നമ്മൾ അത് യൂസ് ചെയ്യുന്നില്ല, അതാണ് ഞാൻ അധികം ഫോക്കസ് ചെയ്ത് പറയാത്തത്. ആൻഡ് അവർ നെക്സ്റ്റ് ഫിഗർ ഈസ്, okay, shape factors equal parallel rectangles in opposite direction. Equal and parallel rectangles, this similar diameter, similar length and breadth particular rectangle placed in opposite direction. The figure is here, this figure. Okay, we had written the first option, that is equally placed rectangle. So here is, there are so many sides, b is the width. ഈ തന്ന ഫിഗർ ഇതേപോലെ നമ്മൾ കാണാം. And area 1 is basal area 1, A2 is there, and length L is shown here, D distance between the both planes are D shown here, B is here. So please find the value of x and y. Find the value of, initially you want to find the value of x and y. X and y കണ്ടു കഴിഞ്ഞാൽ x is here L by D. L എന്താണെന്ന് നോക്കുക, L by D. L by D is x, and y is B by D. And after finding the value of x and y, direct come to this particular table, and x is in this direction, 0.1, 0.2, 0.4, 0.6, etc., and y is B by D is shown here. Intersect the values and find the particular value. Or we can find by using this graph also, that is L by D. L by D means x, right? X value is given in x-axis. After finding the value of x value, you can denote the point here, anything. It is 1. If it is 1, you can find the value of 1 here, and thereafter y value is shown in curves. That is y equal to B by D. B by D is shown in curves. Curve value is the y value, and after finding the original curve we want to find, and after finding the one on the mode and intersect that particular curve, we need, and make a point, and left side y-axis will be your F12 shape factor. So for the case of two rectangles spaced in opposite direction, we can find the value of the particular F12 as, find the x value and y value. X value is L by D, y value is B by D. So what is L and D? What is L and D? L and B shown here. L is here, B is here, D is here. A1 is here, A2 is here. Just find the value X and Y value. Please take, if the question is asking like that, take your data book and find the value correctly. What is L and what is B? The larger side is L, right? The larger side is L. Smaller side is B, and the distance between the two planes is D. And just find the value of X and Y using a table or either by this curve. We can find the value of shape factor for this particular problem, this type of problem. So next question is perpendicular rectangles. Perpendicular rectangles, that is here. Perpendicular rectangles having similar edge. The both figure have a similar edge. Here similar edge മാത്രമേ both rectangles are placed in a perpendicular. So here also, here you can find this Z equal to L2 by B. A1 is here, A2 is here. First we want to find their XY, here ZY. Z is equal to L2 by B. L2 is shown here, B is here. L2 is here and B is here. So L2 by B and Y equal to L1 by B. L1 by B. Okay, L1 by B and L2 by B. A1 and L1, it will be L2. L1 by B and L2 by B. And find the value Z and Y. And here Z is shown in Y axis, Y is shown in X axis. Just intersect the value and find the value of the particular shape factor, or by using this curve, Y by X. That is shown here. And the A method graph you can find it by using this table. Next question is non-intersecting perpendicular equal squares. Non-intersecting squares. Non-intersecting squares means offsetting, which means that one square is placed in particular axis and another one is placed at a particular angle. Which question is asking by particular, we can take this type of figure, take your data, we can find the value of a particular value. That is S by C. S is the distance of particular radial distance of particular space distance. Point distance. It is S and C is the particular E distance. Center space like square distance is given as S, and plane square distance C. S by C. S by C A by C. The graph is A by C. A by C. A is the side. A is the square side, and C is the distance from the particular point to plane A1 in the distance. C. A by C. And S by C A by C, and plot a particular point, and he left side you will get the F12. And like that, take your data book and find this several problems, several figures are there in your data book. Next one is this conical disc. Disc placed in a particular distance. Disc which is placed at a particular distance. Sorry. Okay, sorry. Disc which is placed at a particular distance. Same method is the same method to find the value of shape factor. Same method. Data book here L by R2. L by R2. L by R2 is taking as X axis. L by R2. L by R2 means this L means the distance between the both discs. Distance between the both discs as L. R2 is the second body radius and R1 is the first body radius. R1 and R2. So L1 by R2 as X axis, and is not clear in the old data book. It's perfectly given in your new data book as R1 by L is shown here. R1 by L as a particular curve. R1 by L is the curve. R1 by L is the curve, and L by R2 is the x-axis. Just intersect the particular point, and find left side y-axis will be your F12. So like that, you can see many configurations and many geometries in your data book. many configuration and many geometries in data to find the value of shape factor. So അതൊന്നും മറിച്ച് നോക്കുക and find the values of എങ്ങനെയാണ് കാണുന്നത് മനസ്സിലാക്കി വെക്കുക. ഓക്കെ, then we can move to the next section, or we can do a problem, but time is up. We can continue in the next class. We can continue in the next class. We can problem related to the in your text. Related to the particular